Oh, hi there. Thanks for showing up for your learning. Let's take a look at the next section of the exam review, which is all about algebraic expressions. Okay? Polynomial vocabulary is something that we have not spent very much time at all with this term, and you should not expect to see many questions about it on the exam. Aren't you glad you watched these videos? You get a hint for what's on there and what's not on there. But let's take a look at it anyway. Okay? So, you want to have a nice marked up copy of the exam review for yourself as well. All right, let's go. So when we are, I actually took this question off of the exam review. So there you go. All right, we're going to start right away with simplifying the following expressions by collecting like terms. Okay, so now when we're collecting like terms, we want to look through here and we see, okay, I have 5 multiplied by t plus 3 multiplied by t minus 1 t. Okay, so I've got a bunch of t's together. 5t's plus 3t's is 8t's minus 1t. So one strategy is to put like a box around those and include the sign of the number. So I have 5 plus 3 minus 1. That is 7t at the end of the day. And then other things that I've got there is I've just got numbers. Negative 7 plus 10. Negative 7 degree day. When it gets 10 degrees warmer, it's now a 3 degree day. So it's 7t plus 3. Okay, so that's the fully simplified version. So we've simplified by collecting like terms. The t's go with the t's and the numbers go with the numbers. Make it a little bigger for you. Now up here, we've got ones that have x squareds and x's in them. So let's go ahead and get 3 colors ready. X squareds will go with x squareds. So let's put a square around those. There's an x squared. There's a minus x squared. Okay, and then linear x's, just like a single x, they'll go together. So we'll bubble those with the sign of the number. And then we can combine those together. The last thing to do will be, we've got some number there and some number there to put those together. So let's collect our x squareds first. We'll have 4x squared and minus 1x squared, so that's 3 of them, 3x squareds. And then we'll have 9x minus 2x, that's plus 7x. And then minus 7 plus 9, well, that's plus 2. And that's done fully simplified. There. All right. Now with this one over here, we've got x's and y's. X's and y's are also unlike. They're different. So let's put our circles around our y's with the signs. This is minus 5. It's not 5, but then I subtracted or something weird. It's minus 5 times y. Okay, and then let's get our x's. We'll put boxes around those so that we can see it very clearly. And then put together all the boxes. So 11x plus 3x is 14x, minus 10x is 4x. 5y minus y is 4y, minus another 5y. If you have 4y and you take away 5y, you'll end up with negative y. So this is 4x minus y. And that's what it's equal to, and that's fully simplified. Done, done, done. All right. Now we've got to learn about using the distributive property. But before we do, we should get this part out and say, all right, we have combined like terms. We are good with that. Polynomial vocabulary won't show up on the exam. So you can just remove that. We'll talk about it more after the exam. Okay, so with the distributive property, this is 2 multiplied by the whole bracket. Okay, an example might be something like, let's start writing on the back of this one. If I had 2 times 10 plus 4, this is the same thing as saying 2 times 14. So I should, if I simplify this, get the same answer as 28. 28 is 2 times 14. Okay, so if I multiply this 2 by 10 and this 2 by 4, what will I get? I'll get 20 plus 8. That's equal to 28. That would be the same thing as if I did this bracket first. 2 times 14 would also give me 28. So I need to make sure I do both of those multiplications when I'm multiplying things into brackets. That applies here as well, even when I don't know what one of the numbers is yet. I will do 2 multiplied by x and 2 multiplied by 14. 2 times x is 2x. 2 times 14 is 28. And that's done. Final answer. over here, this negative 3, think of it as a negative 3, not as minus and then 3 something something. Okay, this is negative 3, and it's going to multiply in here, here, and here. It multiplies all the things inside the brackets that are separated by addition or subtraction. So here I have minus 3 times x squared. That's minus 3x squared. Minus 3 times 2x, that's minus 6x. And minus 3 times minus 11 is plus 33. And that's done. Final answer. Okay. And now over here, 2x times 3x squared minus 5x plus 3. This 2x also multiplies every single thing inside the brackets separated by addition and subtraction. So we have to multiply it in 3 places. 2x times 3x squared, well, that's 2 times 2 is equal to 6. X times x squared is x to the 3. We have to add the exponents. All right, 2x times minus 5x is 2 times negative 5, which is negative 10. And x times x is x squared. And then 2x times plus 3, that's plus 6x. And that's done fully simplified and expanded using the distributive property. Now, so we can go back to our sheet, and we can say we've done some distributive property. And let's now simplify expressions by expanding and simplifying. Okay, so first step we want to do here is we need to do these problems in bedness order. So this one here, I have to do whatever's inside the brackets first, but I can't because those are not like terms. So now I have to go outside the brackets and do these multiplications. So let's do this multiplication first. 2 multiplied by this bracket is going to be equal to 4x. That's 2 times 2 times x is 4x. 2 times negative 4 is negative 8. And then we're going to do this multiplication here, which is negative 4x times 3x. And so that will be negative 12x squared. And that's done. All right, this one over here. Take the negative 3 and distribute it in along with the 3. So negative 3 times 2x is negative 6x. And negative 3 times negative 3 is plus 9. And then we still have this minus 7 hanging out outside the party waiting to get in. Okay, we had to do this in bedness order, so we had to do this multiplication first before that subtraction. Now we can do the subtraction because 9 minus 7 is just 2. So this is negative 6x plus 2. Done, final answer. Let's keep going. Over here. All right, let's go. So negative 2 times 3x minus 8. So we're going to distribute this negative 2 in. And then this negative 4 is going to distribute in here as well. So let's do all the distribution in one line. Negative 2 times 3x is negative 6x plus 16, because negative 2 times negative 8 is positive 16. And then minus 4 times 2x is minus 8x. And minus 4 times 9 is minus 36. Okay, so all the distribution has been done. And now we can combine like terms. Minus 6x minus another 8x gives us negative, that's weird, negative 14x. And then positive 16 minus 36 is minus 20. And that's done. Final answer. Okay. So this is how you simplify expressions by expanding and simplifying. Okay. Now, you can't really check these on a calculator, can you? The way I was showing you before, different things that you could do. But you can look at these things and say, like, have I been equivalent at every line? So one thing you could do is work backwards. Minus 6x plus 2, go up a line and say, oh, 2 becomes plus 9 minus 7. Yeah, that makes sense. Plus 9 minus 7 is 2. And minus 6x stayed minus 6x. And then when I go up, oh, I see. Like a minus 3 factor has been pulled out of both of those numbers and pulled into the front. So minus 6x divided by negative 3 would be 2x. And 9 divided by negative 3 would be negative 3. So that all checks out, going backwards. Yeah. So you can get in that habit. I'm in that habit. You want to be in that habit. All right. 4x minus yx. when x is equal to 3 and y is minus 2. We want to learn how to evaluate these things. So I'm going to use two colors here, and I'll put in my substitutions in red. So I'm going to have 4 multiplied by something minus something times something, okay? Well, I'm going to put in x here, so x is 3, and I'm going to put y here. Well, y is negative 2, and x is 3. Okay, now we do this like a Bedmas problem. 4 times 3 is 12. Negative 2, well, let's just do this. Negative 2 times 3 is negative 6, so I'm going to be minus negative 6, and this is 18. 12 minus minus 6 is 12 plus 6 is 18. Done, final answer. Okay, here, this one. So we're going to have minus 2 times something squared minus something all squared. Let's put in our somethings. B is 3, and A is minus 2. Okay, so let's go another line. Minus 2, 3 squared. We have to do inside the brackets first, and we have to do exponents first. So this is 9 minus minus 2, so that's 9 plus 2 squared. Okay, 9 plus 2, well, that's 11. So this is minus 2 times 11 squared, which is equal to minus 2 times 121, which is equal to negative 242. Okay, and your calculator will tell you the same thing. These you could absolutely test on your calculator. And this is where I brought a calculator. Here it is. Okay, this is what it would look like to test this on your calculator. So I'm going to plug in at that layer. Okay, and I'm going to go minus 2. Can't see it. There. Okay, I just need to prop it up a little bit. Okay, minus 2 multiplied by, so I put that bracket there, just like I have in the question, 3 squared minus, put in a bracket, minus 2 and bracket, and the bracket, square the bracket, equals, oh, I got the same thing, okay? So I plug it into my calculator, admittedly very carefully, with all the brackets and things there, and then it evaluates it for me. Mr. Jennings, if a calculator can do it, why do I need to know how to do it? That's a good question. I'm glad that you asked. You'd punch it wrong on your calculator and not know. Okay, be honest with yourself. You would make an error punching it. You wouldn't know how to see your error or find your error, and you wouldn't be able to find it or have an expectation of what the answer should be. When I learn to write it out carefully, I'm also learning to punch it carefully on a calculator. Is really like writing things in this form, writing things in that form, writing things in that form. I write it in the same form on the calculator and I get it right. I'm only so good at using a calculator because I never use one. I do it all on paper. Let's keep going. All right, 3d minus f squared all over 2f squared when d is 3 and f is 10. Okay, cool. So here, write it out. 3 times d, which is 3. You don't have to do it in another color. I'm just being fancy. Minus 10. Okay, I could put that 10 in brackets, but it's not going to change things. Squared. All divided by 2f squared. So 2 times 10. This time I need it in brackets. Squared to show that that's still multiplying. All right. Now I'm going to move this up so I don't run into my face. 3 times 3 is 9. 9 minus 10 is negative 1 squared. Negative 1 squared is 1. So we're going to get there in a second. 2 times 10 squared. Do the squaring first. So this is 2 times 100. Okay. And so 9 minus 10 is minus 1. We're going to square that and get positive 1. And we're going to be dividing by 2 times 100, which is 200. That's equal to 1 over 200. Done, final answer. Okay. Now, write a simplified expression for the perimeter of the following shape. Okay, here's something I notice. There's a few ways to do this. You could say w plus 5 plus w plus 5 plus w minus 2 plus w minus 2 plus w minus 2 plus w minus 2. You could do this. Or you could do it this way. I got 1, 2 of those, and I got 1, 2, 3, 4 of those. So this is 2w plus 5 plus 4w minus 2. Okay? That's how you would write it out if you want to save some time. And then we'll use our distribution, right? So this is 2 times w and 2 times 5. And this is 4 times w and 4 times minus 2. So that's equal to 2w minus 10 plus 10, get the sign right, plus 4w minus 8. W plus w is 2w. So 2w plus 4w is 6w. And then 10 minus 8 is plus 2. That's the simplified expression. The perimeter of that shape. We should go checking some things off on my checklist. It's my favorite part. I love checking things off on my checklist. We did applications with algebraic expressions just now. Fantastic. Oh, wait, we still got more. Still got more. We want the area of the shaded area in the diagram below. Oh my goodness. Okay, let's see what we get here. Okay, this is clearly challenge problem level, right? Right. Okay, let's go. So 10x plus 7, we want an area for the shaded area. So that's going to be area shaded is equal to area big minus area of the two small rectangles. Area of rectangle 1 minus area of rectangle 2. Like we have to take out rectangle 1 and rectangle 2 to get the total area. So the shaded area is equal to, well, the big rectangle is this multiplied by this. So that's 10x plus 7 times 4x. And I wrote that backwards, but it's still going to distribute this way and distribute that way. If I wrote it on the front, I'd have the same multiplications. Anyway, area of rectangle 1 is 2x times 2x plus 3. So it's going to be minus 2x times 2x plus 3. And then we're going to subtract x times x plus 4. So there's my subtract those two smaller rectangles. We'll do our distributions here. 4x times 10x is 40x squared. 7 times 4x is plus 28x. Okay, and now we do minus 2x times 2x, and that's minus 4x squared. And minus 2x times plus 3 is minus 6x. And then we have minus x times x is minus x squared. And minus x plus 4, minus 4x. All right, now we can collect like terms. So maybe I put a box around my x squareds. There we go. And so we got 4x squared minus 4x minus x. So this is 35x squared. And 28 minus 6 minus 4 is 18x. So this is my simplified expression for the area of that shape. All right, so now we've done some applications with algebraic expressions. And let's go to the next row. All right, so now here, solve each of the following equations and show all work. Okay, great, super duper. All right, here I'm going to multiply both sides by 7 because I notice that I'm dividing an unknown by 7. So I do the opposite of dividing, which is multiplying. This 7 cancels that 7. And then you end up with equals x on that side, which is your goal. Some number equals the number I don't know yet. Okay, now I know the number. All right, 7 times minus 3 minus 21 equals x. Okay. Now, how about this over here? Now I've got multiple steps. What will we do? 89 equals 8x plus 25. Well, first, get all your numbers to one side, all your x terms to the other side. All the x terms are already on one side, and I see I'm adding 25 to them, and that's annoying. So subtract 25 from both sides. That will give me 89 minus 25 is 64. 64 is equal to 8 multiplied by some number. I don't want to know what 8 multiplied by a number is. Happens to be 64. So let's divide both sides by 8. And then you get 64 divided by 8. Well, it's just 8. 8 equals x. There, that's the answer we're looking for there. Over here, it's the same layer of question, but there's lots of negatives in there. One thing you could do is multiply both sides here by -1, and all your signs would flip to the positive. That'd be easier, but I'm going to do it a different way. I am going to subtract 11x. Sorry, I'm going to add 11x to both sides. I see that I got -11 of them over there, and that's annoying. I'd like +11 of them. So I'm going to add 11x to both sides, and then I will get -42 is equal to -97 plus 11x. And then let's go ahead and add 97 to both sides. Why am I doing that? I want to get x as alone as possible. So here I'm subtracting 97 from it right now. If I add 97, that'll be equal to 0. So now we will have equals 11x. What equals 11x? -42 plus 97. So that's 55 equals 11x. Here we divide both sides by 11. X equals 5. Now, you're probably dying to know, Mr. Jennings, how do I check my answer using my calculator? Okay, so once you got into this stage here, you go ahead, turn on your calculator and type it in there with this as x. So 42, but it's negative. Whoop, here. -42 minus 11 times 5 equals, okay, I got -97 on that side, -97 on that side. Yay, the equal sign is telling the truth. Okay, let's keep going. Oh, we've got distribution to do here. What a delight. Okay, multiply that in, multiply that in. We're going to simplify things as much as possible first, then push all of our x's to one side, push all our numbers to the other side, solve. So we will have here 12x minus 4 is equal to 32. Now we're subtracting 4 here, and that's annoying, so we'll add 4 to both sides. 12x equals 36. Cool. Let's divide both sides by 12. 36 divided by 12 is 3. X is equal to 3. Okay, quickly check it. 6 times 3 is 18. 18 minus 2 is 16. 16 times 2 is 32. 32. There we go. So check it with your calculator. Okay, over here, again, we just got to simplify as much as possible, and then we get the answer. 3 times 2x, 6x. 3 times 2 plus 6 plus x plus 5 equals -10. Let's keep going. 6x plus x, that's 7x. Okay, we're just going to put this one and this one together. And then 6 plus 5 plus 11 equals -10. And then it's annoying that I'm adding 11 to this number. I'd just like to be adding 0 to it. So let's subtract 11 from both sides. And we'll get 7 times the number we don't know yet is equal to -21. I don't want to multiply that number by 7. So let's divide both sides by 7. And we will get x is equal to -3. And that's our answer. Cool. You can go back and check it, but I'm like so confident that I'm not going to this time. All right. Now this one here, it looks a little messy, but you just do your distribution first. Do your distribution. You're going to tidy first before you try and solve these. This negative here also distributes in. And so that's an important thing that we're testing here. So let's go for that. Then we will have 7x is just 7x. 2 times -9x is -18x. 2 times 3 is 6 is equal to x minus times -4x is plus 4x. Minus times 6 is -6. Okay. Now let's simplify both sides. 7x minus 18x gives us negative 11x plus 6 is equal to 5x minus 6. Cool. Let's put all of our stuff on one side, all of our x's. So we're going to add 11x to both sides. That's going to eliminate x on one side of the equation. This is gone. It's now 0. So we have 6 is equal to 16x minus 6. Well, let us add 6 to both sides to get the numbers all to one side. And then we will have 12 is equal to 16 times some number I don't know yet. Divide both sides by 16. And recognize that 12 over 16 is 3/4. 3/4 is equal to x. Cool, right? Right, I think it's cool. Maybe you don't, but I do. Okay, cool. So there you go. That's how you solve those types of equations. Now, let's take a look. What have we done here? We have certainly done 1- and 2-step equations. We have done multi-step equations. Oh, now equations with fractions. Well, we're going to just do what we learned up here with fractions. We're going to apply these types of things to solving these problems. The rules of fractions don't change. All right. So 13 equals 1/2 times 3x plus 8. Here's one strategy, is to multiply both sides by 2. Then my fraction goes away. That's pretty nice. So I would definitely do that here. 26 is equal to 3x plus 8. You see, that side just got twice as big. It's no longer being multiplied by 1/2. Now I subtract 8 from both sides. Gives me 18 is equal to 3x. And then I divide both sides by 3. X is equal to 6. That's how I would do that one. Right? But Mr. Jennings, what if you didn't do it that way? What if you didn't use your fancy trick? Actually did the work. Well, all right, I'll show you. All right, 13 is equal to 1/2 times 3x plus 8. Distribute that 1/2 in, so that's going to be 3 over 2x. So I divide 3 by 2. I get 3 over 2 plus 4 is equal to 13. All right, subtract 4 from both sides. Gives me 9 is equal to 3 over 2x. And now, here's the trick to turn one of these around. I'm multiplying by 3 over 2. I don't want to do that, so multiply by 2 over 3, both sides. Cool, right? So this 2 will cancel that 2. This 3 will cancel that 3. Okay. And then I do 2 times 9, which is 18 over 3 is equal to x. So 6 is equal to x. There you go. Now, let's take a look at this one. All right, so here I could use a special trick again. Multiplying both sides by 30 will eliminate the fractions. But now it's really too much of a trick, and I just want to show you the step-by-step how to do this work. So let's really zoom in. I'll write a little bit smaller, and we'll go for it. Okay, so we're looking at this question up here. Let's go. So first, we're going to move all our numbers to one side. So I'm going to subtract 1/3 from both sides. So this is now 0, and it's not bothering anyone. So we have minus 1 over 5x is equal to minus 1/2 minus 1/3. Well, we need to get a common denominator there. Negative 1/2 could be written as negative 3 over 6 minus 2 over 6. That's negative 1/3. So negative 1 over 5x is equal to negative 5 over 6. Cool. All right, so now I'm going to multiply both sides by negative 5, because here I'm basically dividing x by negative 5. So if I multiply both sides by negative 5, I get my answer. Negative 5 times negative 1/5 is 1, so that cancels away. I've got x, and negative 5 times negative 5 is 25 positive over 6. So there x is 25 over 6. Okay, and this is how you solve for your unknowns. Do it, love it, prepare it, put it on your cheat sheet if you need it. And if you have more questions, hit me by email and I'll sort you out. Bye for now, everybody. You can also ask me in class. That's also welcome. Bye for now.